let us do another analytical proof that will come from the matrix method. Because we have to keep getting familiar with the matrix method also, because later on in the analysis of symmetry, or if you write a computer program to do any of these calculations, you can't do it geometrically, you have to do it by the matrix method. So, two-fold roto-inversion so let us select the I itself as our origin. So, I is the origin, and let us choose x and y axes in the plane perpendicular to the axis and z parallel to the axis. This is the requirement, and this is the limitation of matrix method, because in matrix method, matrix is always with reference to some axis. See, geometrically when I was doing, and I told you that 2 bar is m, I did not need x, y and z axes, I only needed the axis and the center and the mirror plane. But now if you want to write a matrix for the symmetry operation, you require where is the origin and what are the axes. So, this is a convenient set of axes for two-fold roto-inversion. So, the first step is two-fold rotation. So, let us say that the matrix for two-fold rotation W2. How do you write? What will be W2? What will be the first column of two-fold rotation? -1, 0, 0. Very good. Now, you really did not need that cos theta sin theta formula, although that works, as you can see, because what was the first column supposed to be? The transformation of the first basis vector. What was the first basis vector? That was a unit vector here, E1, which was 1 0 0. If you rotate by 120 degree about z, what happens to this after rotation? It becomes -1 0 0, and that is what you write. The first column is the transformed first basis vector. So, 1 0 0 becomes -1 0 0 on 180 degree rotation. So, that is the first column. What is the second column? Now, you should be able to say quickly. So, what you do to the y axis, what you do to 0 1 0. So, what does the symmetry do to 0 1 0? It makes it 0 -1 0. And what about the third axis? That is the invariant axis, it remains 0 0 1. So, this becomes my nice matrix for a two-fold rotation. Now, but if it was a two-fold rotation, the matrix was complete, but I want to find matrix for two-fold roto-inversion. So, I have to have a matrix for inversion also. Who will tell me the inversion matrix? What will inversion do to E1? Yeah. What will inversion do to E1? If you invert this pen in this center, Inversion maps every point to 180 degree opposite point through the center. So 100 will become minus 100. 010 will become 0 minus 10, and 001 will become 00 minus 1. So you can see there is a slight difference between the two-fold rotation and the inversion. The first two columns are the same. The third column, two-fold roto-inversion, the axis was unchanged, so it remained 001 for two-fold, but in inversion the z-axis also goes to minus z-axis. So 001 becomes 00 minus 1. So that is the inversion matrix. Now two-fold roto-inversion. This means inversion followed by a two-fold rotation followed by inversion. The geometrical operation of followed by is equivalent in matrix language multiplied by, matrix multiplication of the matrix. So inversion follows rotation. So inversion matrix and the two-fold matrix. So W2 bar will be Wi into W2. You remember, we always write the first matrix on the right and the second matrix on the left, and if there was a third matrix then still on the left, because what is the purpose of these matrices? To transform some vector. I want the image of some vector by multiplying it by matrix. So if I multiply a vector with this product, which matrix will act first on it? The W2. So the first matrix is always written on the left. So what do you find if you now use the result? Now interpret this matrix. So this is the two-fold roto-inversion axis. Now if I again interpret in the same way, the first column was telling me what happens to 100. So nothing happens to 100. So this matrix leaves 100 unchanged. 100 remains where it was because the first column is 100. The second column remains unchanged. So 010 remains where it was, but the third column, which was 001, becomes 00 minus 1. Which operation will do that? Reflection in the plane. So this is equivalent to mirror in the, you can say, 001 plane passing through the origin. Okay. So that is a matrix way of seeing that the two-fold roto-inversion is nothing but a mirror plane perpendicular to the rotation axis.